All right, this video is for lesson 2.5, transformations of functions. All right, question 1. What do we got?
Suppose that the graph of function g is known. The graph of y equals g of x plus 2 may be obtained by a blank shift of the graph of g.
Y equals g of x
Plus 2.
plus 2. Okay, I may make y'all a copy of this. Let me find mine. Did somebody steal my algebra book?
Oh, there it is.
Oh. See if it's in this one. It's usually the last thing. Okay. I may make y'all a copy of this page. But it shows you what it looks like when they're doing all this stuff, what the functions look like. So, if we do f of x plus a number, it's a vertical shift. We're going up. We're going up 2 units. So if it was minus, down however many units. Yeah, so that's a vertical shift.
And then up.
All right, number 2.
Suppose that the graph of a function f is known. Then the graph of y equals f of x minus 2. So x minus 2 is in parentheses.
Oh, so like this?
Yes.
Okay, so these are the ones that mess kids up. So when it looks like that, you would think it would go to the left, but it doesn't.
Which is stupid.
It's horizontal and it's to the right. So anytime you're messing with the x's, it's opposite land. Let me just keep this book open to that page. Okay. Number 3.
The graph of y equals negative f of x is the graph of y equals f of x reflected about the...
So, like, does it look like this?
Yes.
Okay, so that's a vertical reflection, which means it's across the x-axis.
So if it's a negative change in the x, so it would be like adding a negative to just the x inside the parentheses, that would be the y
So
axis.
is that what number 4 is?
Yes, ma'am.
Y equals f of negative x
Yes.
is a horizontal reflection. So reflecting across the y. I have a feeling the next one is stretches and compressions. These are the ones that mess me up.
Use the graph.
Okay?
Use the graph of y equals f of x to graph the function g of x equals f of x plus 2.
Okay, so if it's plus 2, take your graph and take each, is it a line
A horizontal line that looks
like this? So take each of these points and just move them up to, does it want, what does it want, like the equation of the line?
No, it literally just wants the graph.
Just graph it, like multiple choice, pick the graph?
Yeah.
Yeah, so if it's like that, it's phrased like this, f of x plus 2 with it on the outside. Okay.
Next one is f of x plus 2.
Like this.
parentheses,
So that's going to go left
left 2.
2 units. So this was f of x plus 2. Okay.
Graph the function g of x equals f of x plus 2 in parentheses minus 1.
Like this.
Yes.
Okay, so that one is left 2,
Yeah.
down 1.
G of x equals f of negative x.
F of like that.
Yes.
So that's reflect across the y-axis. So if your shape is here, it's going to be over here.
What if it's a line
It
of
just
3
stays
points?
there.
It's the exact same. No.
It's already.
What you do is you switch the x values. Change the sign of the x values.
Use the graph. Graph function g of x equals negative f of x plus 2.
Negative f of x plus 2. So that's going to reflect across the x-axis
Then you add 2.
and then up 2.
So it just goes in the order that the equation is.
There's actually a specific order. I got to remember.
Or does it just reflect first?
That one's just going to reflect first. Because what you would do if f of x equals 2x plus 3, right? You would do, if we would swap this out with this, it'd be negative, and then this whole piece changes to 2x plus 3, and then this gets tacked on to the end. And so it would become negative 2x minus 3 plus 2, which would be negative 2x minus 1. That would be the new equation of the function. So order of operations still applies.
I think it's horizontal, vertical, reflect.
Stretches and compressions, I think, are first.
Uh,
So if it's asking to graph the function g of x equals half of f
Okay, wait. G of x equals half
of f of x.
of f of x.
then I have 2 of f of x equal 2 f of x.
Okay, and then you have 2 of f of x.
Are fractions like they compress and then
I got to remember because it depends on which way the compression is. So let me go to this and give you an example. Okay, so again, if original function is, actually let me do a quadratic. X squared plus 2x minus 4. Okay. If it's on the outside, right, it would be 2 and then times the original function. And so from,
stretch plus 1.
it stretches it vertically. So you're looking from, the red is the original, the blue is the new. See how it gets skinnier? It's stretching it this way. You're pulling it vertically.
How would they do that with a line, with a horizontal line?
Okay, so let me show you a horizontal line. A horizontal line like y equals 3, something like that.
Yeah, well, it's a line segment for us, but it's
Oh. Let me think about that. Do we have more than one chance on this one?
yes.
Okay, I think with this one, if this is your original line, your new line would be squattier. If on this one, if the number out in front is a half, I want to say the new line would be longer.
We do not have a squish
They don't have a squish.
So
The original equation. And then we're doing 2 times f of x. So here, let me get a different sheet.
It says just multiply but quantify the number.
You would multiply, but you would multiply the y values times 2. Does that make sense? So the x values would stay the same. The y values would get multiplied by 2.
right, so the line isn't like you don't see it.
So you would have-
Making a box. It just moved.
So your x values are like -2, 0, and 2, and all the y values are 2, 2, and 2. To do this, you would multiply. All the x's would stay the same. These get multiplied by 2. So it should, your new line for this one should be at like y equals 4.
Yes.
And then this one should be like y equals 1.
That's an answer and it's correct.
Is it right?
Yes.
Okay. That's why, I hate these. Parabolas are easier to see. Visually, you can see what's going on. Okay.
Okay.
Anybody else have a question on number 10?
Question 11 is the exact same thing for you.
Okay, so Peyton, what do you have on number 11?
It's the same thing. It's
Like this with it out in front of the function?
with the 2 f of x.
Okay. So yeah, all you're doing is if it's like this, you're multiplying the y value by the scale factor.
Let's put the exact same question.
Is it another horizontal line?
Well, no, it's literally the exact same.
Oh, literally, it may just be an oopsie.
Use graph y equals f of x shown below to graph the function g. G of x equals f of 1/3 x.
F of 1/3 x.
F
Wait, what's your graph look like?
There's a point at
-2,
-2,
2, okay.
0, 2,
0, 2,
and
2,
2, 2.
2, like that?
Yep.
So this time you would take the x values.
And multiply it by
A third. So this would be -2/3. This would still be 0. This would be +2/3, and the y's would stay the same. So your x values squish in this way. Anybody got a different number on that one?
Same x points, just different y.
Yeah. So you're not messing with the y's on this one, just the x's.
I don't have one that.
Yeah, I don't need it.
Yeah.
You don't have one that matches?
No.
Crack.
The shortest line is the one I've selected.
Okay, give me a second. Let me look again.
Might it be a stretch since the x thing was going back? Looks backwards, like if it's plus whatever goes to left.
It's just so hard to do with a horizontal line.
It's not quite within reach.
That one looks right.
Oh, it says dividing the x.
Joseph C is the one that looks right. No? Crack.
Hey, yeah, it divides it. It's backward.
It does the opposite.
Yes.
Shiminy Christmas. See, and that's what I always forget. When you're messing with the x, you do the opposite. So instead of dividing by 3, you'd multiply by 3. So -6, 0, 6.
So would you do 3 instead of a third?
Yeah, you do the reciprocal. When you're messing with the x, you do the opposite. And that's why this stuff sucks. And that's what I was just looking at my notes for, because it shows it here. Like the scale factor here is 5/8, but we'd multiply by 8/5. Flip the fraction, it's the reciprocal. Okay, 13.
Alright.
Mine is g of x equals negative f in parentheses half x close parentheses plus 2.
Right, half x, close parentheses,
Plus 2.
plus 2. Okay, give me your points.
Negative 2, comma 1.
Negative 2, comma 1,
0 and 1.
0 and 1.
And 2, comma 1.
Okay, so here we're going to multiply by 2. So we're going to multiply the x's by 2 first. So it would be negative 4, 0, and 4. The negative out in front, if we're reflecting across the x, would mean we're going to change the sign of all the y's. So now we would have, right, if we're reflecting across the x, it changes the y. So negative 4, 0, 4. So now these are all negative 1. And then add 2 means we're going to go up 2. So we're going to add 2 to all the y's. So all the x's stay the same. If we add 2, these all become 1. So you have to do it a step at a time. Do a piece at a time.
I'm confused why the y's changed to a negative 1.
Because of this one right here.
Oh, okay.
So that's a reflection across the x, which changes the y value. So this is this piece, and then the negative is this piece, and then the plus 2 is that piece. Anybody got a different one on that one?
Yes, but I've got it.
You got it? Okay.
So then we're going to go back to
Hopefully I did that in the right order.
Yes.
Grab some colors here because I think we're going to need them. It's easier. It's easier if you kind of color code on these.
Use the graph of y equals f of x to graph the function g of x equals f of x plus 1 plus parentheses plus 3.
Okay. What are your points?
it's a zigzag.
Negative, negative 4, 0.
Okay.
Negative 2, negative 4.
Negative 2, negative 4,
0,
0,
0.
0,
2, 4.
2, 4,
4, 0.
4, 0. Okay. So first up would be this piece. We would do x minus 1. We do the opposite. I know it messes with your head, but we're going left 1, which subtracts 1 from each x. So we would have negative 5, negative 3, negative 1, 1, and 3. All the y's would stay the same. Then this piece, the plus 3, means we would take the y and we would add 3 because we're going up 3. So now all the x's stay the same, but we add 3 to each of these. 3, 7, 3. So those should be your new points on your new graph. But the key is that this thing should go left 1, up 3. The whole graph should shift left 1, up 3. Yeah, I remember doing this last year. Okay. All right, 15.
Use the graph of y equals f of x, graph the function g of x equals negative f of x.
Just that?
Yeah.
So that's just a reflection across the x.
Yes.
So all that does is it just changes the sign on the y value. So in case you run into a table instead of graphs, reflecting across the x just changes the sign on the y values. Because I don't think we did a lot with graphs last year. I think it was all like tables. And then they had to write an equation from the table. So this is not quite that bad yet. So
Graph the function g of x equals f of negative x, close parentheses, plus 4.
okay, so that one is just going to reflect
Plus y,
across the y
then up 4.
and then up 4. So that one changes the sign of the x values and then shifts it up 4.
You've got a stretch. Show below to graph the function g of x equals 3 f of x.
Okay, 3 f of x. All right, do you have ordered pairs?
Negative 7, 0.
Negative 7, 0.
Negative 2, negative 2.
Negative 2, negative 2.
0, 0.
0, 0.
2, 2.
2, 2.
7, 0.
7, 0. So this is taking the y value and multiplying it by 3. So all the x's are going to stay the same. And so if it's out in front, you don't use the reciprocal. If it's next to the x, you use the reciprocal. So only those two points change, the negative 2 and the positive 2. They'll shift up. Okay. All right, what's next?
Alright, g of x equals f of 2x.
F of 2x like that?
Yes.
Okay.
Speed horizontal compress.
Oh, it's asking what it is, or it wants you to pick it.
No, it's graph.
Okay. So what are your ordered pairs?
Negative 6, 0.
Okay.
Negative 2, negative 5.
Okay.
0, 0.
Okay.
2, 5. 6, 0.
So that's a quadratic. So this time, use the reciprocal times the x. So cut all of those in half. And then the y's stay the same. So again, actually all the points will change on that one.
Use transformations of the graph of f of x equals x squared
Okay, wait. F of x equals x squared, okay?
to determine the graph of the given function. H g of x equals negative x minus 5 open parentheses,
Okay.
x minus 5,
Okay.
close, squared.
So it wants to know the new graph.
Use transformations of the graph of f of x equals x squared.
But what are your answer choices?
Um,
Are they graphs?
we are graphing it.
Okay. So this one, if we go back to Desmos here. So x squared looks like that. And then negative x minus 5 squared. So, and that's right. The negative out in front means it's reflecting across the x. The minus 5 in parentheses says it's going right 5. So black is the original, red is the new on this one. So yeah, reflect across x and then right 5.
Okay, this one's weird.
This is 20.
Alright, so when you're putting it, you're,
Here, let me look.
yeah, gives you to that.
Okay. Use transformations of x squared to determine negative x. Oh, okay. So you're going to reflect it over the x and then a
just
horizontal shift. Why is it doing that? Oh, there it goes. Yeah. Did y'all figure out how to do that with the graph?
I don't even know that one.
Let me pause this for a second. Okay, so Shelby, your number 20 starts out as x squared, but what's g of x?
4 parentheses x minus 1
X minus 1
squared.
squared, like that? Okay, so the 4 out in front means we're messing with the y value. The y's getting bigger. So that's going to be a vertical stretch by a factor of 4. And then x minus 1 means we're going to shift
To the
right
right.
1. Anybody else have one on 20 they need help with? Okay, 21.
They let us have fun with the square root.
And I got a square root 1.
Yeah, on 24.
You want me to jump down to 24, Peyton?
I'm good. I'm gonna see if I can try to
Okay.
figure this out.
Well, since we're getting close, I'm going to go ahead and end this video.